and welcome to Houdini Hive Equinox, right here in Toronto in our hometown. We've got a really exciting week planned for you. We've got presentations here in this room. We've got classroom-based training in that room and that room. We're going to kick things off with a little keynote presented by some staff and some customers talking about some recent use cases and workflows, starting with our president, Kim Davidson. Kim.
Chris, you were supposed to go to the next slide. There we go. Welcome. It's so amazing to have this, and the marketing teams put this on, but so many great customers to have you here today. They gave me this slide and said, you have to present, and it's like, oh, okay. I'm not a presenter, but I'll do it anyway. But you know, you'll hear a lot about Houdini and SideFX over the next few days, but I want to tell you what our secret sauce is. Our secret sauce is not what Houdini is, but it's all of you. And that's really what I want to talk about, our users, where they came from and how it all began. So let's start at the beginning. So in the beginning, there was exactly no users. But let's jump ahead some 14 billion years, and now we have omnibus computer graphics, 1985. So in 1985, we had one user. We actually had 15 users and about 15 developers spread over 3 different sites. So there's sort of a user programmer guy. I don't know if you recognize him, but that's Kim Davidson. And I just wanted to point out 2 things in this picture. We were on dumb terminals that were connected to mainframe computers. So that's basically a dumb terminal is just a key, just to see text on the screen. And we had exactly 1 frame buffer that held 1 image and 1 image only. So if you wanted to see animation, you had to record it to videotape or to film, not done on another floor of this company called Omnibus. But then this thing happened, where we had this wee bang. We were developing this software called Prisms. It was named by the owner of Omnibus. And we were developing this software, and then there was this wee bang in the universe, not a big bang, but a wee bang. And in 1987, they went bankrupt. And so I was able to cobble again some money to buy some prisms. And so in July of 1987, SideFX was born. They got prisms, and we got this to continue and find some users. So 2 years into SideFX's history, we had something like 25 users. And these were our very first user group meeting in Boston. And this was kind of the ones that were present. So we did have more customers, but not a lot. And then these were the things we were talking about, is a couple pages of notes that we took at the user group meeting. I want to point out one thing. We'd actually hired a year before, he didn't come, but we hired our very first programmer, our very first employee, and that was Mark Gallant. And he was working on ray tracing a render, and so that was sort of noted in the meeting notes, even though Mark wasn't a present. But he's still with us today, still writing software, as many of you know. So that's Mark Gallant was our very first employee. And then jump ahead 5 years, we've got our first booth, and we've got something like 70 users, 75 users at that point. And how are we meeting users? And we're starting to now touch more users with our software. We're growing. And I want to show just sort of how we're growing here. So this is a thing of a first 10 years. So we talked up to the first 5 years, but you can see for the next 5 years, there was some steady growth growing in users. So if we're going at 75, I don't know what that is on my slide, but let's say there's 500 users or something like that. And then the next 10 years after that, from up, you see this thing, what's going on here to 2007. So what's going on is all of a sudden there was a democratization of 3D animation. There was graphics cards came out from NVIDIA in 1999. And so our user growth kind of slowed and actually dipped a little bit. I don't know if my numbers are perfect. I'm the guy who keeps this history, but you're trying to recreate some of it. But it was something like this, very close to this. So we kind of kicked around for about 10 years, and we focused on one huge set of customers because we knew if we're going to survive, we wanted to focus on users are so important, customers are so important, and those were the high-end visual effects artists in Hollywood. And that's what we did for most of those years. We still had customers around the world, but mostly those were be taken up by the competition, but we focused on a user set. What do you need? And that's what we did for them. And then from that point on, for whatever reason, this is what happened. If you look at 2007 and onward, there was a steady climb to today, and that includes all of you here in this auditorium. So congratulations. Where are all those users? This is just a quick thing. Our first user actually was Omnibus Japan. So that was actually our very first user was in Asia. Our second user was in London, England. So that was in Europe. And then our third, fourth, fifth, I think were in the Americas somewhere. But I do want to point out that somewhere early on, probably customer number 20 or something like that was in Australia. So we have always sold globally and continue to grow globally, especially now with more and more SideFX staff going overseas and traveling. And what would a slide presentation be without some AI? So I'm not an AI expert, but you know, this is what I did. I asked AI, ChatGPT, I said, how do you make Houdini better? And it gave me 5 really nicely constructed bullets or numbers with 3 bullets under each. I just shorten them to blah, blah. It's a lot of stuff I already know, or we know, or I feel we know because we talk to users, but the last one struck my fancy because it did say get feedback. Feedback from your community is important, and that's what the today and what we've been doing. So my last slide is how do we reach those customers? So how do we touch those customers, including today? Well, just today, this year alone, we've visited 20 countries. We've done 12 school visits. We've done 100 school meetings, 500 plus customer meetings. We've attended 7 conferences and showed and demoed those. We've done 11 Ignite workshops, 6 hives, and 64 presenters at those hives, 38 hugs. We've done 40, we've answered, well, I hope we've answered, well, we've taken 46,000 some odd customer emails. And of course, I have to finish with today. So you guys are a reason that Houdini is so great. We like to listen, we want your feedback. So all I want to do is say thank you and keep your feedback coming. Thanks so much. Up, Cristin Barghiel.
Thank you, Kim. Morning, everyone. Right. Next slide. There you go. I'll talk to you about the state of the art in Houdini 21. I'm basically starting that topic, and then throughout the day, you'll be hearing from a lot of people on that topic. But first, Houdini 21. Yes, 21 releases as of last month. We're very proud with this latest release, which encompasses hundreds of features spanning almost the entirety of the CG landscape. And this is a reflection of our mandate as a company to go beyond being the industry standard for visual effects and simulation, and to give you a choice to use Houdini's uniquely powerful architecture and philosophy in every aspect of your work. There are many new aspects about Houdini 21 that we're excited about. One of them is the latest rigging and animation toolset that is now production ready, that is GPU accelerated, and it comes natively with physics built in, auto rigs, and whatnot. So let's take a look at that briefly. This is Harry, one of our little characters that we built. He's all built in with auto rig components that take basically seconds, minutes to put together and animate it really fast with both traditional and some new techniques that we've created specifically for our tool set. But, you know, physical simulation. Yes, we've grown beyond that, but it still remains the cornerstone of our effort in R&D. It really is the pinnacle of our effort. And this shows you the latest of a granular solver known as MPM. Name doesn't matter, but it's a granular solver that is one of those first solvers out there, multi-solvers that is, that combine different materials that is starting to make it really hard to tell what is real from what is not. So we got a lot of comments from people, some of you, you know, industry experts, and some just novices going, is that really CG? So this is really, really key to us to maintain that really high bar on physical simulation and realism. So what are our priorities? Not surprisingly, if you've tracked our efforts over time, our fundamental priorities have not changed, because for us, getting the fundamentals right is more important than anything else. And that's strengthening our core technologies, basically making the frameworks really strong, because then you can build features on top of them, but if the foundation is not strong, everything ultimately crumbles. And the other thing is enhancing the user experience, and we do that in multiple ways. I'll show you a bit of that today, and you'll see it from others also later today. And all of that is built on a strong sort of rock bedding of proceduralism, which really stands for non-destructive workflows, revisability, optimal cooking, as we call it, of Houdini networks. So that's really it in a nutshell, and it continues to be the driving force for us as an R&D team. All right, so some of those core technologies, let's go over them. We used to be known as the particle software. Yes, we had a powerful particle system software in the 90s. We started with that, but we've gone way past that. So this is just a list of our physics solver in Houdini, and they really cover the whole gamut of physical simulation that you can do out there. So there's Pyro, which obviously is about fire and smoke, Flip, which is fluids, liquids of all kinds, Vellum, which is a really fast hair, cloth, muscle simulation software, MPM, the one that you saw in the clip just before now, that does really well with granular materials. And the latest one in Houdini 21 is Otis, which stands for Organic Tissue Solver, which we're using for muscles, but we also plan to extend to GPU-accelerated hair and cloth. And here's a quick example of how Otis was used for muscles to put this creature together in Houdini 21. There's a lot that goes on under the hood here. There's a whole simulation, of course, that happens, but there's the whole setup of the muscle system that we've worked on. It comes with a standard muscle rig that makes it very easy for you to build any biped like this, and then also to transfer the muscles to another biped. It comes with machine learning skin and muscle deformation to make it really fast. So it's a very powerful system that encompasses a number of our recent efforts that go beyond simulation. You know, even the lighting and rendering of this is done with Houdini. And what about other initiatives? So there's Solaris, and this is lighting, look dev, and lighting, layout, look dev, and also comes wrapped in with Karma, which is our renderer. In fact, it's multiple renderers. One runs on the CPU, and it's very powerful, and the other one is Karma XPU, which runs equally on the GPU and the CPU and gives you really great performance, leverages the speed of the GPU. And very soon in the future, we'll have another Karma that's based on Vulkan that is going to be like real time or near real time to give it even greater performance for your interactive work. KineFX is what you saw at first. This is our rigging and animation software. And then Copernicus, which is all about image processing. Let's take a quick look at Copernicus, which is not just 2D. It is a unique architecture that lets you blend 2D and 3D and add time to it as well. Basically, you get into 4D and leverages all the power of Houdini. So you're not relegated just to doing image processing, but you can import volumes and meshes and export volumes and meshes and do terrain work and all of that, all in Copernicus. So and you can see some of the beautiful materials that you can create, but also you can do simulation. Nothing stops you in Houdini from doing anything you want in any context, and all the contexts in Houdini talk to each other. This is one of the most powerful and unique things about our software. So there you go. You have physics throughout Houdini. It doesn't stop. And then the pipeline, which is the glue that brings it all together. Part of the reason why Houdini was successfully adopted, even in the early days when we were just a particle system, was that it had very capable input and output abilities. It was a very flexible, very bendy tool that you could plug anywhere into the pipeline. So having a strong in and out system for working with other DCCs or game engines or your custom software is very, very important. So those three listed on the slide are maybe the top 3 ways in which you interface Houdini with everything else, but there are other ways as well. So Houdini Engine, which is an API that lets you plug Houdini's capabilities natively into other packages and also run it in batch mode. PDG and top stand basically for task management, but very sophisticated logic built into that lets you run things not only at a large scale, but do it really, really efficiently. And the third one is Onyx, which is an open source inference engine that was our first entrance into machine learning, building that foundation. And on top of that, now we're building solutions on that. So here's an example of some of the solutions we're building, and this is terrain, which also, by the way, is way, way more powerful and realistic in Houdini 21. We have a new erosion system that's really great. Hopefully you'll check it out. And this is interactive machine learning brushes that automatically generate terrain that can look like the Alps or the Rockies or what have you. And we'll be doing a lot more on that front. Also, something to notice here, while you do have parameters and all that, what you expect to see in a system like this, you have also interactive controls. So Houdini, even though it's procedural, I think it's all about node networks. Well, yes, it is philosophically, and also that's how all the data, the DNA of your work is stored as node networks. It doesn't mean that you're relegating to interacting only with a node network. There's a lot that you can do these days in the viewport that makes you feel truly enabled and free as an artist. So now, speaking about the user experience, here's more of that. So this is some of our latest Pyro work. This is an infinitely running simulation that lets you tweak things as things go. It feels almost like you're in a game engine here, although you are in a DCC. And so everything is running super fast. It's GPU accelerated, and those handles are there to let you, tweak the results of the simulation as well. So there's a lot of interactivity and specialized, customized interactive tools in Houdini to make things really palatable and easy to make, to get to the result you want really fast. And here we're back to Harry and the KineFX tool set. This shows you how quickly you can build a rig in Houdini 21 using auto rig components. You can see the components at the bottom, and you just basically click and drag, and you apply them, tweak the position, and as you are doing this, the character to the right is basically live. So you can at any point go and check to see how your rig is coming together. You can see you have lots of controls there to pick not only what rig components to add, but also what those controls look like. And there's the rig coming together on the right, and very soon we'll be playing with that to see, hey, in a couple of minutes, maybe less than minutes, maybe this is a minute, really, we have a rig that's active, and off you can go and animate that. So very, very fast. Getting you going really fast is important. And those are a couple of ways you can do it, and the other one is recipes or presets is a synonym to that, which is us spending a lot of time building Houdini networks for explosions, for this, for that, that you have on a Houdini shelf. You just click on that or click and drag, and boom, right away, you've got at least a starting point, if not the actual result that you want, where you just change a couple of parameters, and then you can light it, render it, and you're done. So that's the kind of productivity and reach that we want to get to, and we believe we are at that point already with Houdini 21. Please don't read everything that's on this slide. This is just to show you, excuse me, in the past 10 years, how much innovation we've put into the software. Houdini, as you heard from Kim, our company has been around for 38 years, and we've done non-stop innovation for 38 years, but just in the past 10 years, so much has changed. So now to talk about some of those really essential features in Houdini, we'll start with Chris Rydalch, who is one of our senior UI and UX experts, and also one of our top experts in Solaris. Please welcome Chris.
Thanks, Cristin. Yeah, I'm lucky I get to be not just at SideFX, but part of the amazing team in R&D. So I want to talk to you this morning a little bit about Solaris. As Kim and Cristin have illustrated, SideFX's DNA is solving your problems and figuring out how to make your daily work better, make you more productive. And a few years ago, it feels like not very many years ago, but it was 8 or 9 years ago, SideFX set out to revamp the lighting and rendering in Houdini. And around that time, a tiny company you might have heard of called Pixar decided to open source, to the amazement of a lot of people, I think, in the industry, open source a key part of their pipeline, and that was USD. The timing was fortuitous, and after some investigation, Solaris was built on USD. So what is Solaris? Think of Solaris as the umbrella term for this USD-powered ecosystem in Houdini. A big piece of that is LOPS. We love our OP acronyms in Houdini, if you don't know this. Don't know that already. LOPS is that lighting and look development context that Cristin alluded to. This is where you work natively with USD, and it has become an indispensable part of any USD pipeline. The other big piece is Karma. This too is a new rendering engine that Solaris gives to you. We've got 2 render delegates, one Karma CPU, which is this bridge from the legacy lighting and rendering pipeline built around Mantra into this new USD-based world. And Karma XPU is this next evolution powered by GPUs. Now there's way more to Solaris. A little bit of is outlined here on this slide. We've got a nifty little piece of technology called Husk that lets you render from the command line your USD scenes with any render delegate. And one of the brilliant wins with USD is this third-party integration. Typically, integrating a renderer or a plugin is a lot of work for our third-party partners, getting those into Houdini. But thanks to USD and its Hydra architecture, it is a significantly easier task. Because we're built around USD, all those USD integrations like Material X really just come together and are at your disposal. So one question we get a lot is why USD? Now I've talked a little bit about the whys, but as many of you know, adopting new technologies such as USD can be difficult because any change is hard on the technological side, but also on the human side. So sometimes we'll get customers in frustration, they'll say, Solaris would be great if you just took out the USD bits. And I want to paraphrase what our lead architect, Mark Tucker, has said about that. He said it a few different times, but essentially, Solaris could not exist without USD. I'll repeat that. Solaris could not exist without USD. If Solaris was not built on USD, SideFX would have had to invent a scene description that was multi-threaded, that was production-proven, that was scalable, composable, built with collaboration in mind, and we would be many, many, many years behind where we are now. Karma and Solaris would not be where they are today. And also, all of you would have demanded, rightfully, that we have USD compatibility anyway. So, Solaris being built on USD really has set us up for success. And thanks to you, our customers that have adopted and embraced Solaris, it's getting better and better at an accelerating pace. If you haven't started your USD journey, we invite you to look at Solaris and continue to give us feedback to make it better and better. The future is really, really bright. And with that, we'll pass to Sam and Abe from Real Time. Thanks.
Hi everyone, I'm Sam Taylor. I'm the Head of Innovation and Development at Realtime. I'm in charge of our R&D efforts and new tech and training at the studio. I also run our junior training program called the Level Up Program.
Hi, I'm Abe. I actually joined through the Level Up program just over a year ago, and now I'm a Houdini technical artist. So Project Violet. So Project Violet is a collaboration project with SideFX, and that's to demonstrate the new features and workflows with characters in Houdini. This time we've worked with the MetaHuman plugin, which is new to Houdini 21, to propose a approachable yet flexible full human workflow that leverages both like the production readiness of MetaHuman with the simulation capabilities of Houdini.
So what's changed since the last phase of Violet? So you may have seen phase 1, which was the little teaser we put together. This time we've moved away from the more stylized look we had there to be basing it on a scan from 1024. We've expanded the rig functionality, we've integrated an approachable mocap workflow, we've updated the ragdoll system to make it more procedural, we've added the full muscle system and tissue system to it, and we've got various layers of wrinkles going on here. And she's also got a cool new haircut. So why MetaHumans? So on top of the already incredible fidelity that you get from MetaHumans, bringing it into this kind of workflow offers a whole host of other benefits. You have the consistent mesh to begin with, so you'll get consistent UVs, so you can reuse masks and attributes between your MetaHumans and your characters. You get the consistent skeletal structure, and you've got a rig you can match that people might already be familiar with, and then we can build on top of that. We have the flexible input from the MetaHuman creator, or you can use mesh to MetaHuman like we did here, so you can have your own custom character in there. And you also can make use of Live Link for performance capture, so you kind of get the best of both worlds. And speaking of Live Link, it allows you to kind of very quickly batch through large quantities of facial performances. So this is like raw, straight from a filmed plate of Regina from our team, put straight onto our character. And what's cool about this is that this is driving the controls for our character, so we can build on top of that and take this further. So what's amazing about this is a starting point, not the end point.
So you've heard about it today already, but I just want to push home about the auto rig builder. So it can be used to rapidly generate a very modular rig via a really nice, elegant drag and drop system. So it already has a host of rig logic, but you're able to add as much as you'd like to this at your own will. So since MetaHuman come in neatly packed with a really nice tagging system, it means that you can, once you've done it once with a MetaHuman, you can use this for all MetaHumans, and that's true for everything that we're going to show you today.
Yeah, and on the topic of tags, MetaHuman allows us to basically almost fully automate the ragdoll setup. We can grab the driver joints tag here and basically use just those joints to drive our proxy objects for our ragdolls. So we can, with just a tiny bit of tweaking, so say if you want to remove the fingers and stuff like that, that's the only kind of manual editing you need to do here, and then mapping it back to your original rig. And in 21, the new Scene Animate makes working with ragdolls even more powerful and easy to use.
So I feel like a really important thing to talk about is the animation within Houdini. So a great new feature that was added in 21 is the animation catalog. And this allows you to very rapidly create a library of poses and animations that can be created from motion clips or live link. And this just really helps to very quickly get your animation up and running. You don't have to use the whole pose as well that you've saved. You can just use the eyebrows or the hands or whichever part you want to. And this can also be blended with your animator's animation that they've already done in your scene. So altogether, it really reduces the lead times for animators. Something that we had to do was bring in the MetaHumans.
The masks?
The MetaHumans masks. And basically drive these in specific areas of the face. And this can already be done. It comes in with this, but we needed to render it. So this was being brought into Solaris. And by doing this, it meant that we could actually add our own mask, our own level of displacements and roughness and color, just to add that extra bit of nuance to the skin. And now we're in Houdini, we might as well use the Houdini-centric workflows that we have on offer. So we wanted to add an extra layer of variation to the microdermal of the skin. And this is because when the skin gets stretched, it actually gets shinier as your pores get thinner. And when it gets compressed, they get thicker. So your skin gets a little bit more rough. So what we did here is we created compression and stretch maps with direction. And these can be used in conjunction with COPs. And this is just to create that effect that I was talking about.
And as you saw earlier, there's the new Otis muscle systems here with the built-in Otto toolset. And when I saw this in the launch, I was like, I really want to see how this transfers to a more slimmer, slender character, because a lot of the examples were really muscular dudes or big kind of muscly brute characters. And as you can see here, it blends between these characters pretty flawlessly, and it's incredibly stable as a system as a whole. And we'll go diving more into this in our presentation later in the week.
So all of these combined allow you to reach a really high fidelity character surprisingly quickly. That was a lot of stuff to go through, and like Sam said, we'll be talking about this later in the week. But yeah, it's a really nice character, and I hope you enjoyed. Thanks for listening. Over to you, Rob.
Thanks. I'm Rob Stauffer. I manage the technical consulting team at SideFX, and within that team is SideFX Labs. So I'm going to talk a little bit about SideFX Labs today. And I think really the best way to talk about SideFX Labs is talk a little bit about the history and where it came from. A little over 10 years ago, Houdini didn't have much of a presence in game studios. Some didn't know about us at all. And those that were using us just for certain tasks, the typical things you knew that Houdini could do. Pyro, destruction, things like that, exporting things to texture sheets. And for the most part, they struggled to adopt Houdini further, and they really couldn't take advantage of all that Houdini had to offer. At the time, part of the problem too was that there was just a lack of Houdini knowledge at these studios. Most of the artists or Houdini artists out there were in film and TV, visual effects companies, made adoption difficult. They didn't have that expertise in-house to not only advise the studio to where labs could benefit their pipeline or Houdini could benefit their pipeline, as well as just what else it could do besides effects work. There was also a steep learning curve compared to some of the software that they were using at the time. So there was a lot of struggles there. So we came up with something called the Game Development Toolset. And here's an example of it here, right there, down below. And the idea there was to provide a set of tools that packaged some of these common workflows up and made them a little bit more accessible. So things like taking Pyro and making texture sheets out of it. And it was a little bit more just digestible and artist-friendly. Some of these tools were things like texture sheets, like you see here, vertex animation textures, RBD export to bones, flow maps, and we had some third-party integrations like reality capture. And the main idea behind labs was that at the time it was still the game development tool shelf. It morphed into labs later. Was things like rapid prototyping. We'd meet with a customer, we'd find out what their pain points were. We worked outside of the typical Houdini dev cycle. We'd release these on GitHub. We do rapid prototype, get some feedback, go back, do it again, and again and again until we got something useful for them. And a lot of these tools were meant to lower that barrier of entry. There'd be something that would help somebody along, something that maybe required a few nodes to set up, and we package it up into an HDA that made it more accessible. Right here is a very early example of that. This is Unreal 4, and here's some of those early shelf tools at work. There's the VAT tool is in there, texture sheets are in there, flow maps are in there, just to give you an example. And also at the time, Houdini Engine was in its early days, and a lot of these tools were designed to be able to bring into your game engine, whether it was Unreal Engine, Unity, or even a custom game engine, which made it even more accessible. People didn't have to leave that game engine while they were developing and then do something in Houdini and export it out. They could stay in the engine and build out whatever it is they were working on. Here's just another typical example of a labs tool. This is, you're just drawing a curve, and from that curve, the tool is generating a bunch of cables wrapped around each other, industrial size cables. And again, tools like this were also accessible inside of a game engine. So this was all generated from common procedural workflows that people were using Houdini for in games. And so by creating these tools, we made it a little bit more accessible to the game artist who maybe didn't have as much Houdini experience or the know-how to build these tools. Since then, we've grown quite a bit, but the goal remains the same. It's to wrap up some of these common workflows and create, tight integrations, as it says here, with Houdini and some of the software that you use every day. We have released hundreds of tools since then, from enhancements to some of those early helpful utility tools to complete tool sets like biomes for generating realistic environments. We have handy geometry tools like simple shapes or a hexagon grid generator. We have enhanced our game engine plugins and PCG connections from Houdini to Unreal Engine. And we have new third-party integrations like Zebra AI for compression of volumes, RealtimeUK, and Endava, which you'll hear more about in a little bit. Here's just a quick look at some of those biome tools. The tool uses climate-based generation to figure out where vegetation should go in your environment or on your terrain. We have handy user interface tools to really visualize what your result may or may not look like, and try to be as artist-friendly as possible. And there's also Solaris integration here for Karma rendering. So how do you find us? Well, SideFX Labs, like I said, generally operates outside of the Houdini dev cycle. It is downloadable through the launcher or through our website, and also it still lives on GitHub where you can have access to the tools that way. So there's a quick little history of labs, and with that, I'm going to hand it over to Jules Glegg.
Hey, what's good, folks? I'm Jules Glegg. I'm the tech director at Software Games. Let's talk about video games. So if you're making a video game, a few relevant problems are going to come up for you. First is performance. We like 60 frames a second. That means about 16 milliseconds every frame to do all of the work required to paint. That's collision, physics, enemy behaviors, audio, script execution, the whole lot. There's a lot of cheats and tricks we can do to avoid work or move it around, but a couple of relevant ones. We can do work ahead of time, get it done before you even run the game, that's great. And if we can offload it to the GPU to run in parallel, that's awesome too. One more problem, game teams are typically much lighter on programmers than they are on designers. and artists, which means it can be easy for programmers to be a bottleneck. There's a strong incentive for us to build tools, get designers and artists building stuff the way they want, get them moving fast, and get the heck out of their way. Hard to breathe. Okay, cool. So there is a game we're talking about today. It's called Ambrosia Sky. It's coming soon from our studio. And it is a single-player sci-fi clean-em-up game where you will be attacked by, blocked by, and eventually clean away various horrible species of alien fungus. It's made in Unreal Engine 5, and Houdini Engine is used throughout the fungus pipeline, a phrase that I feel I must apologize for. So Houdini Engine, as has been mentioned before, is a way to invoke Houdini by name from within your other tools and use its power for a moment to achieve things that your tools couldn't do on their own. I'd love to show you an example right here of some of the things Space Fungus will do so we know what we're talking about. Oh, cool, we got the audio. All right. So fungus will rush at you. It'll block off hallways and pathways. It'll spawn at you in huge quantities before your eyes. It'll also participate in the world simulation of our game, conducting power, being flammable. It has a physical structure that you can burrow into, tunnel, and so on. There we go, we fixed the light. And finally, some species of fungus are actually volumetric terrain. You can dig holes in them, find things behind them, walk across them, or destroy them to clear your path. All without telltale voxel appearances. So cool, a few problems that we have to solve there. Fungus should spread out. It should have this beautiful kind of organic pattern as it rushes you, which is a swarm behavior. Those are pretty hard to do at runtime. And so we found ourselves looking for another solution. And we found one in the space colonization algorithm, this really cool thing from the Algorithmic Botany Institute. It mimics the behaviors of nature in slime molds, spreading out to seek food, in trees and their branches spreading out in search of light. Super cool. And we thought maybe we can make this part of our workflow. And with Houdini Engine, we were able to build an entire pipeline that replaces nav mesh in the Unreal Engine and allows us to path these things really cheaply. So level designers are able to author spaces in the game right in the level editor in Unreal, exactly as they would normally. The level geometry is surreptitiously sent over to Houdini Engine, where we process it and generate these beautiful distributed mycelial splines across the world. And that generated navigation geo just comes back into Unreal, where it can be used for gameplay immediately. And it's totally transparent. The level designer never even leaves Unreal. We don't make them all tab. They stay on task. Another place where Houdini is helping us out is the volumetric damage that I showed you. So this is a custom pipeline. A 3D artist can put together fungus in any shape they would like, a variety of shapes per species. Tech artist then decides how they would like this thing to fall apart, whether they want it to melt, to crumble, to fizz and bubble, whatever they would like. And then in the game engine, we are selectively winding that animation forward only for the damaged regions of space. And the cool thing about this is that the artist can iterate freely on the look and feel of fungus as you clean it, as it grows in, and there's no system changes. We're completely out of their way. And because it's vertex animation texture-based, it's all on GPU. We can run hundreds of these cleaning animations at the same time, even on handheld hardware. It's pretty awesome. And the workflow is so fast that I'm actually going to demo it live. I didn't even edit it. I wanted to be honest with the timings. See if we can get that slide to appear. Might have to vamp as the video loads. Here we go. Great, cool. So I'm in my editor. I'm going to drag a colony of what we call the exploder fungus, guess why it's called that, into the world. Immediately set up how I would like the player to encounter it. Send the level geometry over to Houdini, generate some pathways for it to follow. Say, I would like this to grow at the player straight away. I'd like it to grow in pretty quickly over the course of, say, 10 seconds. and back, drop into gameplay, and I'm immediately testing my encounter where I can see how it feels, how it's blocking the space, come back out, maybe change the randomization seed or identify some no-go areas. Very, very fast iteration loop, thanks to the role of Houdini engine in the pipeline. So some takeaways there. Houdini engine can expand what the game engine can do for you. It can expand the kind of tools you can build for your artists and designers, not just for producing visual assets, but actually to produce data that's useful for your other gameplay systems if you're a programmer. The Houdini outputs can be made with a little creativity, interactive. They don't just have to be fountains in the corner, interesting animations. You can make them reactive to the player's actions. I really recommend starting simple. There's a ton of learning resources that you'll learn about through the event for Houdini, and there's a ton of pre-made stuff in Unreal on Fab as well that you can just get together and kit bash. The important thing is just make something, make a silly game, make a serious one. The field needs your voice. And if you'd like to know more about the technical underpinnings of this and a ton more technical detail, there's an extended session Thursday at 11:15 where we'll unpack how all of that stuff works. So thank you for your kind attention. It's over to Tom.
Thanks, Jules. I'm Tom. I work in R&D at SideFX, and I'm here to talk about Copernicus, which is new in 20.5, and in 21 we made a bunch of improvements to it. So what is it? It's a GPU accelerated image processor. So it lets you do a bunch of things that I've listed here, and I'll go into detail about it later, but essentially you can generate textures and materials, apply them to your assets, generate terrain, simulate stuff, process live and offline renders, and then obviously because it's built inside of Houdini, it interrupts with the entirety of the software. So when it comes to textures, you can build them yourself. Of course, it's all procedural and node-based like the rest of Houdini, so you can easily make variations. You can either export those maps to use in a third-party renderer if you're into that, or you can directly live link them into Karma, our render engine. You can also export those maps through the Houdini engine and use them in your favorite game engine. When it comes to texturing assets, because Copernicus supports 3D, you can bring in geometry directly inside of COPS and texture it there. So I can bring in this robot, bake maps like occlusion and normals and all that good stuff, either through COPS or Karma, and then I can go ahead and use those maps to texture my asset, like this little robot, and then I can either render it in Karma or like send it to Houdini engine to use in a game or something like that. Height fields, so you can, because they're all images, right? You can build terrain using Copernicus, and like Cristin mentioned earlier, we have a new erosion solver that runs on Copernicus, so you can do believable erosion on your terrain and then texture all of that inside of the same context. Simulations, well, Copernicus makes it really easy to build your own solvers. It supports nano VDBs, so this GIF you see here is of a 3D pyro simulation, so it's a smoke simulation that runs on your GPU using nano VDB, so it's all sparse, and it runs almost in real time, or pretty much in real time. But we also ship in some other built-in solvers like Flow, which is a 2D fluid solver, sorry. And then we also have live render and offline render processing. So because renders are just images, right, you can process them inside of COPS. You can output a bunch of AOVs through Karma or your preferred render engine and process those AOVs to, for example, give it an NPR kind of look like this cube here. And some of those COP networks, you can actually run them directly in your viewport. So if you look deving a shot, you can apply some glow, some whatever to make it look the way you want to, and that's directly in the viewport, but then you can render your final frame and use that network again when you're done. And seamless integration is a big part of what makes Copernicus really great. because you can build your model inside of our geometry context and then bring that in. You can bring textures in to drive simulations, then you can use those textures in our render engine, and then you can do what we call slab comp, which is basically applying filters to your viewports. So here's a little couple examples. And then I have two more examples of this seamless integration. We have this really cool asset made by Tiny Bagbot, which is this kind of mechanical bore, I guess, and it's all built in Houdini. So you have, it's using the geometry pipeline, the animation pipeline, Copernicus for the textures, and then rendering in Karma, and then you have the whole thing. And the last thing I want to show you is an example of using Copernicus to drive simulations. So you have this grain sim, and it's being driven by this flow underneath, so you can see that. Oh, that video just stopped, but you could see that this grain simulation was being driven by carbs. And with that, I'm going to pass it over to Jakob, Nick, and Jeff.
Thank you, Tom. Hello, everyone. Today, we're going to talk about ML volume upres. Oh, my name's Nick Culver. This is Jeff Guttin. This is Jakob Ringler. We're going to talk to you about ML volume upres today. With Houdini 21, you can use machine learning to increase the resolution of your volume simulations. With either a GPU or a CPU, you can simulate volumes, train a model, and harness ML to work for you. Okay, that's cool, but why should you care? In a real production scenario, there are a few ways this could come in handy. The most common one in VFX that happens every day is that you create a simulation, you show it to your supervisor, and they love it. They come back later and they say, I just want a bit more detail. If you sim at a higher resolution, your result changes. You need that exact same sim, just with a bit more detail. There are also a few other applications this can be used with. So you have multiple similar simulations, like a carpet bombing scene in an action movie. You can train on one high-res simulation and then apply that model to all the other explosions. It's also handy to iterate fast on a low-res simulation, and then when you find a look that you like, you can add more detail to all frames in parallel. And lastly, you can up-res volumes that are too big to efficiently simulate in the first place. Clouds are a good example of this. I'm going to hand it to Jakob, and he's going to tell you how it works.
Thank you, Nick. Thank you, Nick. How does it work in everyday life? You first need to train your model, and for that, you need a high-res simulation that you can use as an example. To create example pairs of your high-res data, we downsample the high-res by our desired up-res factor. Those two volumes become the input and target of our network. Because GPU memory is often limited, we cannot fit the entire volume into VRAM. We need to split those up into tiles. This all happens automatically before being fed into the neural network. The network then tries to learn and understand how those low-res inputs should look at a higher resolution. Once the network finishes training, we can apply the model to new, unseen low-res simulations and up-res them. And Jeff will show us how that can look.
What's up, guys? So on the left, we have our input low-res, and on the right, we have our ML up-res of that same simulation. The low-res VDB is being enhanced, and we're able to see more detail. In case that side-by-side wasn't clear, here's a wipe of the same simulation. The big point here is that the ML up-res looks crisp compared to the low-res. In this contact sheet, the input low-res is a simulation that we want to train and up-res. The naive up-res is just changing the voxel size of the volume without using any trained models. The ML up-res is using a trained model from Houdini. The reference high-res is a simulation we trained on that has the details we want to add into the ML Upres. Here's a wipe of a project I worked on with both Jakob and Nick, as well as Dmitry Vlasenko. It's a wipe between the low-res input and the result of the ML enhancement example. The still image is great to show how much of a visual change we have after the ML model was applied. Why does this matter? This toolset allows you to save time while increasing quality. That doesn't happen very often. This adds value to old simulation setups that delivered great looks. Why wouldn't you take advantage of all the extra caches you have on disk? This runs on a GPU, and CUDA unlocks the fastest path. But if you don't have a CUDA-capable GPU, don't worry, these tools still all work on a CPU. Houdini is successful because of the artists who use it. We are excited for all the people using this new ML approach and are looking forward to all the creative ways artists find to maximize the potential. And like with everything else in Houdini, the artist is the author at every procedural step. Gonna hand it over to Judith. Thank you.
Thank you. I am indeed Judith Crow, and I lead our strategic partnerships initiatives at SideFX. And I think, whether you're a content creator or a tools developer, we're all experiencing volatility and uncertainty at the moment. And I know that I'm not alone in asking how are we going to navigate this moment, and where global political and economic forces and technological challenges and changes are upending whole industries. Well, I've started, as Kim is, thinking back in history to look at how we might navigate this. And Apollo 13 was actually just released in IMAX this last week. And so I had reason to recall my experience of working on the original movie 30 years ago. And so as I consider today's environment, I think there's some themes that are really worth revisiting. I'm hoping that most of you have seen and remember the movie. On their way to the moon, an explosion damages the Apollo rocket. The crew need to repurpose the lunar module as a kind of a lifeboat, and things look really dire. One of the crew members is sick, and there won't be enough oxygen to sustain them all. But with some very creative problem solving from both the crew on board and from mission control back on the ground, and some application of duct tape and plastic, they managed to save the day. They never make it to the moon, but they return safely. And that makes way for future successful lunar missions. So it was considered a successful failure. And in many ways, it's kind of a parable for our times. One day we think we know where we're headed, and the next, nothing is as it should be. Everything seems kind of catastrophic and insolvable, so can we fashion ourselves a lifeboat and kind of hack our way out of this? I loved working on the movie even more than I enjoyed watching it. And in some ways, it felt like making the movie had its parallels in the telling of that story. There were a lot of tricky problems to solve. There was a lot of collaboration required, and a great deal that was learned that we carried forwards into future productions. We had our own successful failure in that we did not win the Academy Award for visual effects. That went to Babe. However, for us, it was a foundational project that led to a lot of other things at Digital Domain that we were able to be proud of. So back then, as we've heard from Kim, Houdini was but a gleam in his eye, and of course, Prisms was actually the software that was in use. That was my go-to problem-solving software. We had a hybrid pipeline. It was a combination of part practical and part CG. And so Prisms was used for processing data from motion control and live action shoots. I used it for solving visualization problems. I used it for automating batch processes. And of course, I used it for creating effects. So Prisms became the backbone, really, of our pipeline. And today, those original foundational roots are really to be found in a much, of course, stronger incarnation in Houdini. So 3 decades later, Houdini is the much matured version of the mindset that we had in place then. And so that was providing us with procedural control that we could rapidly problem solve with under pressure. Now, in practice, of course, we, SideFX, are part of a much larger ecosystem. And in that ecosystem, we are all interdependent. So whether you're a vendor who designed the tools and hardware, or perhaps you are mission control, and you're ensuring the communication lines, or perhaps you're on the crew in the lunar module, sick and sleepless. Either way, we are in it together trying to solve the problem at hand. And at SideFX, I look at partnerships as a way of working with other tool and service creators to strengthen and to extend the reach of Houdini and the way we can play in that larger creative ecosystem. Through that, we can better support all of you to develop the kinds of workflows that are best for your needs. Now, where our technology has a good fit, partnerships also provides a way for us to engage in and to learn about other industries outside our core media and entertainment business. So one of the things that we do is we pay very close attention to some of the more disruptive or fast emerging trends in the broader ecosystem that we're a part of. And we try to bring Houdini's unique capabilities to the fore. So, as you might expect, there are certain kinds of themes that begin to emerge. I can't enumerate all of them here, but I keep coming back to a few areas of focus where I think partnerships can do the most to advance our goals. So here's a couple of examples, well, 3 to be precise. The first is synthetic data generation. And that's particularly at the moment in the field of computer vision, and where they need to be able to provide very comprehensive, clean, sometimes rather large data sets for training machine learning models. And here, of course, Houdini can provide procedural variation and intelligent ways of annotating data sets. You'll be hearing a little more about that in a moment. And then secondly, cloud deployment with Houdini Engine has all sorts of potential to deliver content to people who have perhaps less 3D expertise. So if you can deliver to web browsers, deliver to game engines for things like user-generated content or perhaps visualization, there's a lot of different applications there that we're starting to explore. And then, perhaps rather unsurprisingly, a third topic that's really occupying us a lot these days is exploring hybrid workflows that combine the best of traditional visual effects practices with newer AI models and workflows. We're thinking about who we need to be partnering with that will help us give creators the kind of blend of control and speed that you need. But doing all of this while not compromising on data provenance, ethical concerns. Well, I am not going to be the one to make all of this more concrete. Fortunately, we have 2 people who can speak to some specific partnership initiatives that we've been undergoing recently. First, you're going to be hearing from John Hanzelka from Endava on the topic of synthetic data generation and annotation for computer vision applications. And after that, we'll be hearing from Paul Ambrosiussen describing a workflow for cloud-deployed Houdini engine on Amazon Web Services with the goal of delivering content in a web browser. And I realized that little QR code is a bit mysterious. It does not take you to my Bitcoin donation portal. It's just a LinkedIn thing. So don't be too concerned about clicking on it. So thank you very much. John, over to you, John.
Thank you, Judith. Everyone, my name is John Hanzelka. I'm the head of synthetic data at Endava, where I lead a team that's building AI vision solutions for our clients. Earlier this year, had the opportunity to partner with SideFX to release a set of tools inside of labs, which Rob talked about earlier, that is specifically geared for generating synthetic data out of Houdini. So today I'll be sharing what synthetic data is, why it matters, and how we use it Houdini at Endava to deliver production-ready AI vision solutions to our customers. So first off, what is synthetic data? AI is only as good as the data that it's trained on, and having access to quality data makes or breaks the development of an AI vision model. But collecting this data in the right volumes is often the hardest part of this process. It can be very slow, time-consuming, and costly as well. But this is where synthetic data comes in. Synthetic data is a pretty broad term that gets thrown around a lot in different contexts. This could be things like text data, tabular data, sometimes audio information. For the context in which I'm speaking about it today, synthetic data is artificially generated imagery that is used to train and evaluate AI vision models. It can reduce or even replace the need for real captured data, especially in cases where that data is difficult to collect, costly, or may contain sensitive information that's not fit to be used for training ML models. But beyond that, synthetic data gives us a unique set of superpowers that help us develop better AI. We can generate purposeful data that captures all the nuance and variety that exists in the real world. And we can use that data to ensure that these models are being trained on ethically sourced as well as unbiased data. We can also streamline our development cycles by reducing the time needed to collect data and actually train the model by shortening that iteration loop. So put simply, it helps us create the right data at the right scale and at the right qualities to power our AI solutions. So this pressure gauge video is a great example of synthetic data in use in a real-world application. This is a vision model that's been trained entirely on synthetic data that is now running on a real-world video. The model is evaluating the position of the needle relative to the pressure range and then providing back the actual dial reading. The magic here is that no real-world imagery needed to be collected to train this model. And I think the interesting thing when you watch this video is that you can see the raw stream of how the model is interpreting the real world. It's queuing off some false positives and some other gauges in the scene, but we can instruct the model on what we want it to pay attention to and only run downstream processes after it's kind of queued in on that. So how did we do this? The first step is always starting with the contents. So inside of Houdini, we created a photorealistic procedural gauge that could model all the different representations of the real world that we want to represent. This includes things like varied lighting conditions, camera angles, dial values, and pressure ranges, just to name a few. We can then use the synthetic tools that we've created in Houdini to configure this into a format that is directly consumable for training an AI vision model. And this includes detailed ground truth information like 2D bounding boxes, segmentation masks, and key points that allow us to guide the model and instruct it on what we want it to learn about the real world. A case like this really illustrates how synthetic training data can be effectively transferred to the real world and is directly applicable to industrial equipment monitoring, which can help improve factory safety and increase the longevity of your equipment. As a side note, this gauge scene is available in the content library if you want to download it and check it out for yourself. So at Endava, our work is mostly outside the world of media and entertainment. We're working with a broad range of industries from healthcare, automotive, sports science, infrastructure. All of these clients have a very differing set of requirements for how we need to make their data. For example, in healthcare, we're creating patient data that can be used to create advanced diagnostic tools. In automotive, we're helping to create more diverse data for automotive scenarios. In sports science, we're creating advanced anatomical models to help better evaluate athlete performance. And in infrastructure, we're creating data that can help us better inspect public utilities. Again, to serve this range of clients, we needed a solution that could be fully controlled and can adapt quickly to each new use case. And this is really where Houdini came in for us. We were able to quickly build this capability on top of existing powers. We love the fact that it's a single extensible platform that allows us to quickly implement new features when we need them without having to get bogged down by development cycles. Our tech artists can do it themselves. And this car crash from the Houdini 21 is really a great example of what we love about Houdini. It gives us out-of-the-box capabilities that allow us to get up and running with new cases without getting bogged down in developing complex foundational components from scratch. So we can build off these realistic visuals and implement machine learning concepts like labeling that we're seeing here that allow us to annotate our data quickly and begin model development without much setup time. And thanks to the proceduralism that is at Houdini's core, we're able to implement this with all of the variation that we need to be able to actually effectively train a machine learning model. Normally, manually annotating complex imagery like this is a slow process that is super prone to human error and very slow, and in many cases just impossible to label this type of data with any type of accuracy. So these synthetic tools really allow us to have the built-in process that is consistent and scalable, as well as repeatable, which is very important for us as well. Kind of going off this a little bit more, since our tools are built to work directly with any standard Houdini attribute, any attribute that you make in Houdini can then be annotated and used as a signal for training and evaluating the performance of your model. Like we see here with the damage attribute that we're then transferring into an actual labeled signal for our model. Dynamic and procedural annotations like this allow us to go beyond just basic object labeling and enable us to develop more advanced scenarios and vision capabilities that would not be possible, with manual labeling. Now, the car crash scenario is a bit of an extreme case, but it's easy to see how you could apply capabilities like this to more common everyday applications like manufacturing defect detection, where you want to be able to ensure that the products coming down your factory line are free from any, damages or defects that may be encountering throughout the process. But we also recognize that synthetic training data is just the first step on a very long journey of training AI vision systems. So we're working to build more features that enable the full end-to-end of this process. This includes things like CV training nodes directly inside Houdini that allow you to take the data that you've created and then train your model and assess its performance without having to get bogged down in all of the complexities of standing up your own environments if that's not really your specialization. We're also enabling cloud scalability. Again, this is all about generating large volumes of data. So the quicker that you can make that data, the faster you're able to iterate and get to a result. We're also expanding the automation of annotation. So this will include things like auto-labeling USD scenes. Again, about getting your content with annotations and labels faster is the way that we try to operate here. And then finally, educational content. There's a lot of black boxness that's around the world of synthetic data and AI, so just making it easier for you to get up and running with these tools and understanding how you can apply your skill set to this domain. The goal is really about having a foundational set of tools that you're able to build on top of. Last thing I want to mention is that I want to emphasize that these aren't just demo tools. These are the same tools that we're using every day at Houdini to deliver production-ready AI vision solutions to our customers that are really transforming their businesses and enabling them to kind of enter the world of AI. So, one of the things on a personal note that really inspires me about the Houdini community is just how creative and ingenuitive that, I think that's the word, doesn't matter. But I'm just really excited to see what you're all able to do with these tools, because it's a passion project for me that I really enjoy, and I think tech artists and Houdini artists really have a lot of capability to bring into the world of AI. So thank you very much, and I will pass it off to Paul.
Hi everyone, my name is Paul Ambrosiussen. I'm a tech artist at Bismuth, and today we're going to be talking about Houdini on the cloud. So we've seen what Houdini is and what it can do, but what I wanted to do is just talk a little bit about a different use case, how you can actually take what you've built and deploy it somewhere else, and that is Houdini on the cloud. So why would you be interested in using Houdini as an outsourcing tool on the cloud? Well, first of all, Houdini, as we know, you can boil it down to essentially a flexible compute engine. You can put data in it, Houdini does something with it, and it gives you something back. So you can think of it as a perfect tool, or platform rather, for any arbitrary data processing. So we often think about, games, VFX, and so forth, but there's many use cases beyond that. And one of those use cases is by Arquiz, and here's a little teaser about that, in which we'll be presenting more about in a talk tomorrow. So that was a use case where you have a company who has a vision to deliver a certain tooling to their customers, and they need a platform in order to do that. In that case, this is Houdini. But they don't necessarily want to have their end users use Houdini. They just want to give them the power of using Houdini. So let's say you're a clever developer called Moritz, and you work in Houdini, you've got Houdini installed on your computer, you've installed the license server, you've installed all sorts of plugins, Qt, Python, whatnot. You open up Houdini, you create your Houdini file, and while you're working in Houdini, you give Houdini instructions on what you actually want it to do. I want you to modify these parameters, I want you to export this geometry, so you can do whatever you want, really. All the use cases we've seen before. So then Moritz, very proud of his setup, sends it over to Mai in this case. Mai tries and opens it, doesn't work. Well, why doesn't it work? Well, in this case, Mai may not have Houdini installed on his computer, or he doesn't have the license server configured correctly, or he doesn't have certain plugins installed on his computer, or he's missing certain dependencies. So that's a lot of things for Mai to figure out in order to be able to use Moritz's work. So, for most people, this isn't really a problem because you all live in the Houdini ecosystem. So what does Moritz do to solve that? Well, since Moritz is smart, he says, hey, let's take that setup, all of my dependencies in which I've installed Houdini, and install it inside of a Docker image. And we'll talk more about what Docker is tomorrow. But essentially, you can think of it as a virtual environment in which you install everything you need in order for your system to run. So Houdini, the license server, the dependencies I mentioned before, all of that, you can think of it as putting it inside of a box, right? Houdini is just something that sits in a box. And so now you can abstract the idea of working in Houdini to just putting some files inside of the box, and you get something back from outside of that box. In this case, an export of a BGO. So now what can Moritz do? He can take this box that he created, and he can give it to Mai. And now the only thing that Mai needs to do is take his Houdini files and tell the instructions that he wants Houdini to do, put those in the box, and the box will give the result back to Mai. Mai is not concerned at all about installing Houdini, installing the license server, and all the other things that he would need to do in order for it to work. He just knows there is a box, doesn't know what's happening inside of the box, but he knows that he gets something that he needs. So taking that concept of abstracting, what Houdini is and how to run it, you can take it a step further, and you can deploy such a system on, for example, a cloud environment like AWS. So that box that we were just talking about, you can upload to a cloud environment in which you can then take that same concept of your Houdini files, putting it in the box on the cloud, and the cloud will give you back your result. That is what you can do with Houdini on the cloud. So what does that mean? Why would you want to do this on the cloud? Well, first of all, that means you can run it from any client, right? You can run it from any device. It doesn't need to have Houdini installed on it. You can run it at any scale. You can also run it with any specifications or hardware specs. And you only also need to pay for the actual compute you use. So running it on any client, what does that mean? Well, that means essentially abstracting away what Houdini is and how to use Houdini on the device you're actually using. So imagine a use case where you have a simple iPad app where you can do some drawing, you can do some sketching, you can do whatever else, but you want to be able to use the power of Houdini, but you can't install Houdini on that device. That is what, for example, a cloud infrastructure allows you to do. You have a thin client in which you create your instructions, but the actual compute happens on the cloud. You can also make it run at any scale. You no longer need to work with just one computer. If you want to run it on one node, that's fine. If you want to run it on 2 nodes, that's fine too. But if you need 10,000s of Houdini instances running, you can do that too, right? So that essentially means that volume and throughput of what you want to do with Houdini no longer becomes a limiting factor for your product or service that you would like to deploy to your users. You can also run it on any hardware specs. So that essentially means that the hardware you're using no longer is a limiting factor for what you can do with your computer or your setup. Because imagine now you working on a simple laptop, you can, for example, make the use of AWS to, for example, run a fluid simulation that requires thousands of gigabytes of memory, because you can tell the cloud environment what it is you actually need to use, once again allowing you to run Houdini on literally a phone if you wanted to. Another benefit, as I mentioned before, is that you pay as you go for what you actually use on the cloud. So typically when you work with Houdini, you need a beefy computer, which means an expensive initial investment of being able to do that. On the cloud in this case, you take away that risk and you offset that large initial cost and spread it out over time. You only pay for the actual compute you use on AWS, for example, for your product. So if you have a service and you want to just try out something, this is a fairly low risk you can take because the compute that you use is the only thing that you actually pay for. So cloud is, of course, awesome, and we probably all have use cases that we can think about and what we'd like to do with it, but we're probably not all cloud engineers. We don't know how to provision AWS infrastructure. So by partnering with SideFX, we did a collaboration between Bismuth, SideFX, and AWS to create Project Aurora. And Project Aurora essentially is AWS infrastructure as a tool that we give to you as an open source and free sample you can use to extend what we've built. And the use cases that this allows you to do primarily focuses on use cases that are not farm use cases, right? Where you just submit a job and you get something back. We're looking at the use cases such as the thin client that I mentioned before, where you can use it on, for example, your web browser, inside of your laptop, inside of your phone, or as part of a service you offer to your customers. So what is it exactly? It's that box that I was talking about. So everything in green, that is what Project Aurora gives you. All of the cloud provisioning, the cloud runtime, all of that configuring is what we're going to give to you so that you as a Houdini user only really need to care about building your Houdini files. And with that, if you're interested in this, please come check out the talk tomorrow. And by that, I'll hand it over to Chris.
Thanks very much, Paul. My name is Chris Hebert. I lead the marketing team at SideFX, which for us is events like Equinox, as well as the learning material. So how many people have seen this drawing? Hands up if you've seen it. Basically everybody. This is an old drawing, and we see it on the internet basically every week. Pops up on some Reddit forum. It's old, and I would say 10 or 15 years ago this totally applied. But SideFX has a UX team that has been very busy at making Houdini easier to use, and we've been very busy at creating learning resources. So we have way more than were available a while back. So now I think it's more like this. Houdini is a lifelong journey. You'll never master it. As soon as you think you have, the R&D team releases another version. So you'll never master it, but it is very, very achievable to become good at it. And I know that because I've been with SideFX for 10 years and I've seen thousands of people go from zero to talented artists over time. Totally achievable. So speaking of learning resources, we're going to go through a few of these. So we've got the Houdini Learning Portal. We've got Houdini Foundations lessons, Houdini Docs, project-based learning, content library, Mardini Game Art Challenge, Ignite workshops, certified schools and instructors, Houdini Academy, and learning licenses. Let's jump in. So the Houdini Learning Portal, or HLP, is sort of your first place at sidefx.com/learn. It's the first place to go where everything's accessible via there. We've got a whole new learning portal coming soon, later this year. It might be December 31st, 11:59 p.m., but it's coming later this year. And it'll be a whole new experience, a better way of sort of capturing, especially our learning paths, which Aliskar Hasanoff on my team is working on, an amazing person that's going to be bringing those learning paths together on the portal. Robert McGee authored the Houdini Foundation's book. The book itself is a couple of versions old now, but there's been some updated videos and PDFs that accompany these as well that are available at sidefx.com/foundations. The docs team is amazing. Like, imagine being able to keep up with the R&D team. So obviously, RTFM, start there. Project-based learning. We started with Project Titan years ago now. Maybe you've heard of it. Since then, we've released Project Grote, Dawning, Turbulence, Greylight, Pegasus, Elderwood, Skylark, and there's about 5 more in the hopper that are coming soon. These generally accompany a lot of learning material around them and show sort of a use case scenario, whether that's for games or animation or VFX. The content library has over 150 assets. You can use these for learning, so it's a good way to sort of jump in, go into the network, see how it's been done, see how it's been put together. Generally speaking, our latest demo material will be in there as well, so you'll be able to see sort of the latest features. So check that out. Community-based learning. So we've got Mardini, which happens every March. Daily art challenge. The amount of creativity that comes out of that is ridiculous. People can enter every single day for 31 days and still have a job on the side. It's insane. The Game Art Challenge just wrapped up, so the winners are announced on the website right now. How to Houdini, it's going to be it's coming out soon. It'll challenge people to create tutorials around Houdini. And Houdini Battles is something that Deborah Isaac leads around the world, but we'll certainly have one here this week, so you'll get to see it in person. Ignite workshops are classroom-based workshops, similar to what we've got going on this week in the 2 classrooms. We've been all over the world this year in 2025. Every continent almost, and many, many, many cities. So it's been super exciting to see all those people getting into classrooms and getting hands-on with Houdini. Certified schools. So we've got schools teaching Houdini all over the world, but some of them go beyond and apply to become certified, so they work through our education team and go the extra step to get that check mark of approval from SideFX. And speaking of check marks, we are just announcing instructor certification. So instructors around the world can take a test and become certified and show that to the community and to their educational institutions. The education team has just launched this. They are excited about it. They want you to apply. So jump in. Houdini Academy, we launched this a couple of years ago now. There's about 2,500 friendly members helping each other learn Houdini. It's our official Discord server. We've got 75 helpful Academy advisors from around the world, sort of handpicked people that are the most generous at sharing the knowledge. And SideFX staff are on there as well, helping people through. So it's a safe space for learning Houdini and helping each other learn. And finally, some people think Houdini is expensive. First of all, we've got Indie, which is the most amazing deal ever if you're making less than $100,000. But if you're a student and you can prove that, you can get a free, it's not free, $75 license, and it's a full version of Houdini FX. And I mean, the best deal ever is Apprentice, which is fully free, and it's got a watermark and a couple of limitations, but otherwise it's a full version of FX and perfect for learning. So jump into that. And with that, I want to say thank you, everybody.